Catnaught's blockchain system for certifying forest management compliance is unique because it offers all the benefits of blockchain technology, but specifically adapted for use in the forest products industry. This video will explain how Catnaught's blockchain system works and give you the principles of blockchain needed to create your own forest products supply chain accountability system. In order to implement a blockchain system for your forest products supply chain, you will need three things: a server at your organization with a blockchain pool program, a server at your supplier's point of manufacturing with a blockchain pool program, a GPS unit on every truck that delivers a load of wood to your supplier's point of manufacturing. This doesn't cost as much as you might think. Depending on conditions, can be as low as $25 per year. Prior to discussing how the system works, we have to first come to understand the concept of hashing. What is a hash? A hash is simply the output of a program called SHA-256 that creates a unique string of letters and numbers for any given input. The string of letters and numbers it creates will always be the same, as long as the inputs are the same. So it's a good way to make information private, but still track the information through a process and link it back to the original event. An example of a hash would be if you put the GPS coordinates into the SHA-256 program, you would get the hash. The useful thing about SHA-256 for our purposes is that this output is unique to the GPS coordinates we gave it. No other latitude-longitude coordinates on the planet would produce the hash we got for those coordinates. However, the information is also private, because if some random person were given the hash, there is no way they could determine what the inputs were. Without knowing the inputs, the hash is just a string of letters and numbers. Next, a brief discussion of a work order system might also be useful. Some manufacturing operations produce batch quantities of things like 200 pallets or 1 roll of paper. And in such operations, it is often useful to account for the use of raw materials by means of a tally sheet, generally called a bill of material. This bill of material is simply a record of how many and what kind of raw material went into the making of a given finished product. Kind of like a recipe. For example, a typical bill of material for a roll of paper towels might be 1 bale of NBSK, 1 bale of BEK, and 2 gallons wet strength. When these bill of materials are sent to the machine operators to make the product, they become part of what is typically called a work order. That also tells the operator how much they need to make and other details about the order. Once the product is made, the work order is marked complete and typically sent back to the accounting with notes on actual consumption and that sort of thing. Implementation of a blockchain system requires the manufacturer to have a basic work order system. Conceptually, one can think of a blockchain system in forest products supply chain kind of like spending bitcoins. The GPS unit on the wood delivery truck generates a Bitcoin upon delivery. The Bitcoin authenticity is verified by the system prior to use. The Bitcoins go into a pool of other Bitcoins in the mill. When the mill goes to make a product, it takes the appropriate amount of Bitcoins out of its pool and spends them on the product. This transaction is verified by the system, and those Bitcoins are removed from the mill's pool and attached to the product. When you receive the product, the Bitcoins are verified by the system and then added to your pool. At which time, when you manufacture your product, the process repeats and on down the supply chain it goes until the Bitcoins are permanently removed from circulation when it's sold to the final customer. Since there are already an abundance of very good systems to establish a chain of custody for transferring of these Bitcoins, this video will focus on explaining how the Bitcoins are created in the manufacturing process. 1. After GPS units are installed on the trucks delivering wood, the load number, load weight sequence factor, and load origin GPS coordinates are hashed when the truck arrives at your supplier's point of manufacturing. This hash is uploaded to your server, which, since it already has a database with all GPS coordinates of forbidden areas, can combine them with possible load numbers and the mill's desired weight sequence to generate all possible hashes from areas of concern, and check those hashes against the hashes uploaded by the point of manufacturing. 2. The point of manufacturing. Let's say it's a mill that is receiving the load has a work order scheduling system that was given a database or pool to store delivery hashes in as well. 3. Each delivery hash added to the mill's pool of hashes is also appended with volume of wood for that delivery. 4. When mill generates a work order for next product, their work order system pulls enough hashes from the mill pool to cover the volume needed for that work order. For example, if each hash was appended with 25 tons of volume and the work order is for 75 tons of product, then the mill's work order system would pull 3 hashes from the pool. 5. These 3 hashes would then get hashed to make the work order hash. Notice how the SHA-256 program takes a large amount of information, 3 hashes, and condenses it down to a single string that is unique and could only have been made from the 3 hashes above. 6. After the work order is completed, the hashes selected for it are hashed, and the last 4 digits of the work order hash are archived in the mill's pool and uploaded to your server. 7. Your server then validates the work order hash. Work order hashes are able to be validated because your server already has all the possible hashes available in the mill pool from the delivery hash upload. Therefore, your server would be able to quickly determine which hashes in the pool were used to make the work order hash ending in E319. If your server determines a hash in the mill pool that has been used once already is necessary to produce the work order hash E319, then the server will know that work order is invalid. If your server finds 3 hashes in the mill pool that are marked as available and produce the same hash from the SHA-256 program as the one on the work order, then the server will validate the work order hash. Once a work order hash is validated, the delivery hashes from the mill pool used to validate it will be marked as used. 8. For the next work order, the mill system pulls the requisite amount of hashes from their pool to cover the volume and adds the last 4 digits of the previous work order to the hash. 9. The hashes pulled for the work order, combined with the last 4 of the previous work order, are then hashed when the work order is completed. 10. This process repeats, ad infinitum. So, how is all this an improvement over our current chain of custody systems? First, all the information is private. Privacy enables sharing. How? Try asking one of your current suppliers for the GPS coordinates of their last forest harvest, and then try asking them for a random string of letters and numbers that you can check against a list of prohibited strings. Which question is likely to get a better response? Second, blockchain is much easier, although conceptually more difficult to understand. Once the system is implemented, there's literally no paperwork needed to keep it going. No more certificates, verification on sometimes working websites, none of that. Third, blockchain is safer. The risk of environmental fraud or Lacey Act violations becomes non-existent because instead of auditing a random sample of loads annually, the blockchain system audits every single load, every single day. We have seen the benefits of blockchain technology, and we believe in its power to be a revolution in forest product certification, which is why we're sharing a literal how-to manual for free in this video. Please feel free to copy our methods. They work. Or contact us at www.catnot.com if you have any questions. Thank you.